All right, this is a problem from Alex, and it wants you to write a polynomial function of lowest degree with these two zeros, a 2/3 and negative 1/3. The 2/3 has a multiplicity of 2, and the negative 1/3 has a multiplicity of 1. We also need to have that the y-intercept, that is when you plug in a 0, the output is -4. All right, so just a couple of things to remember, a little side note, that if we have x plus 2 is a factor of a polynomial, then that would mean that the 0, if I subtract, our 0 would be x equals -2. And so I think we're getting kind of comfortable with that. Now, if we have something like 3x minus 2 is a factor, then we'd say, okay, well, 3x minus 2 equals to 0, add the 2, we get 3x equals 2, divide by 3, we get x equals 2/3. So when you have whole numbers or integers as the part of your factor here, like x plus 2, x minus 5, things like that, it's kind of nice and easy to identify the zeros, and then in that way it's easy to go backwards. Now, if we have a coefficient in front of x, that's what's giving us actually these fractions. So I like to keep that in mind, because now if I'm told, if you look at that first part here, 2/3 is a 0. Well, 2/3 can come from this factor, 3x minus 2. So I am thinking still opposite, so we have a negative inside there. But because I need to divide by that 3, I'm going to have that coefficient of 3. Negative 1/3, let's think about where that comes from. So it's going to be a plus. It's going to divide by 3 also, so it's going to have a 3x, and then we're going to have a 1. And you can double check that both of those would get you the zeros that we would need if you set them equal to 0. Now, multiplicity of 2 means that we'll have a power of 2 on the 3x minus 2, and a multiplicity of 1 means that we have a 1 on that 3x plus 1. So right now, it looks like our function is going to be equal to 3x minus 2 squared times 3x plus 1. Now we can have different stretches and shrinks going on vertically here. And so I'm going to put an a in the front. And this is the number that we're going to actually change in order to make sure we satisfy that f of 0 equals -4. So like right now, if I plug in a 0 for all of my x's, I'm going to have 3 times 0 inside there, 3 times 0 over here, and then I'm still not quite sure what a needs to be. But you can see that plugging in that 0, this first term here, that's going to be 0 minus 2. That's really -2 squared. This is going to be 0 plus 1, which is really 1. And so we have f of 0 is equal to some number times -2 squared times 1. Well, -2 squared is 4 times 1. And so when I'm plugging in that 0, I end up that I would normally get a 4. So what this is saying in our little directions here is that they want us to get -4. So we're going to have that a equal to something. So that way when we multiply it, we end up with -4. That's what we want. F of 0 is supposed to be -4. So really it comes down to solving this little equation. A times 4 equals -4. Divide both sides by 4. That gets us a is equal to a -1. So then our polynomial can be written, f of x equals, we're going to put -1 in place of that a. And we're going to keep 3x minus 2 squared times 3x plus 1. Now that's beautiful, and you could check and see if Alex accepts that. If it wants it multiplied out, you can easily do that. I would start by squaring this. So I'm going to say or. So that's an answer. Or I would square that 3x minus 2, which if I distribute all that, we'll get a 9x squared minus 6x minus 6x plus 4. And this whole time we still have a -1 in the front of all that, and then we also still want to multiply by that 3x plus 1. So if I combine like terms, I'm looking at 9x squared minus 12x plus 4 multiplied by -1 I'm going to change all those signs. Well, actually, I'm going to save this one for last. So now I'm going to actually multiply that 3x plus 1 to everything. So I'll take 3x times 9x, that's 27x to the third. 3x times negative 12, that's negative 36x squared. And 3x times 4, 12x. And then going the other way, 1 times everything, so we'll get a 9x squared. I have a little typo somewhere, but it looks like it's going to be a negative 12x plus 4. All of this times negative 1. So combining any like terms in here, looks like a negative 36 and a 9. That would be a negative 27x squared. 12x minus 12x, those cancel. And so then I have just a plus 4 and 27x to the third in the beginning times negative 1. So final here would be f of x equals negative 27x cubed plus 27x squared minus 4. So there's a lot of work in distributing there and lots of chances for a small error, so hopefully yours agrees with me. If not, just add on to the post below. But I think that this very first way, without actually multiplying it out, would be the perfect way to do it so you don't make any mistakes on that. And the big idea here is to make sure that you make your a equal to that negative 1. So hope that helped.